Hello everyone, in this tutorial we'll be going over how to plot forces in OpenFOAM. So here are the files for this tutorial case. We have the new, our modified airfoil 2D tutorial that outputs force data, and this is the original that comes directly from the standard OpenFOAM repository. And these two scripts, I'll explain later, plot the data that is output from the modified case here. So let's take a look at the change we need to make in the case file in order to output force data. So it's very simple. You just make one change in the control dictionary, and this you just append this pretty much to the end of your normal control dictionary file. Here is where you define the groupings of the force recordings. So this is you give the name, I'll just name it airfoil, and then you give the patches. So you can have many such groupings if you have different sets of patches that you want to record forces for. So this checks the walls patch, which is the whole airfoil in this tutorial case. This is the center of rotation about which moments are calculated. This is the output control. I'm having it set at 5 to output forces at every 5 time steps. This is the pressure field name, the velocity field name, the density parameter, which we've defined to be this, and of course to write out the forces that are calculated. So once you do that and you just run the simulation, you can see that I've already run it to completion beforehand. So this is the new file that is a result of our changes to the control dictionary. It's called post-processing. So you can see inside there is our grouping name, airfoil, and then we have the time at which the recording started, and then the actual forces data file right here. So if we take a look at that, we see it's a series of the force recordings with a specific format. Here we see the center of rotation reiterated as we've specified in the control dictionary, and this is the format of each of these lines, each of these entries. So it's time, then the pressure force, viscous force, porous force, and then the pressure moment, viscous moment, and porous moment. So here you can see the time here, pressure force vector here, viscous force vector here, porous vector, and so on for the moments. So there are many ways to process this file, this raw data file that is output from OpenFOAM. I personally like to use a Python script to process it into a simpler format, and using gnuplot to plot the data. So here's my Python script that's included. As you can see right here, it's plotforces.py. And here we specified where the forces file is, and then this little function turns each line into a data structure, rather a dictionary, so that we can more easily manipulate it. And here I initialize the quantities of interest and then loop through all the lines and then add them to the dictionary. So for drag, I wanted to add the pressure force and the viscous force together. And for lift, the pressure and the viscous in that direction, which is the Y direction, and the moment, which is in the Z direction, I want the pressure and both the viscous components. So after that, then I output this process data to a simplified file, which I've named forces.txt, and then we close, and then we call this gnuplot script, which acts on this new processed file. So let's look at the gnuplot. It's very simple because I've processed it. So I could just say, using the first column, the second column, plot the lift, first column, third column, plot the drag, which is the lift versus time, drag versus time, moment versus time. and it creates a very nice plot. So let's run this. Plot forces.py. As you can see, it gives you a very nice plot from which you can zoom in and such. So you can see it converges. Notice the values may not be physical because the axis of orientation, the way this handles the free stream, is at an angle rather than horizontal, so your force and lift needs to be rotated, and the moment is not at the quarter chord, it's at some other point. 0, 0, 0 is not at the quarter chord, basically. So, but if you just do those simple adjustments, you can calculate the proper moments and forces. And so now we see that this forces file was generated here. This is the one I've generated and processed in the Python script. Okay, well, to sum up, we use the standard OpenFOAM utility to output raw data for forces, and we've processed that file. You can choose to plot directly from that file if you can by some other way. There's many ways to do it, but I've chose to process it into a simpler file, then plot it in a simple gnuplot script. And that's all it takes to gather force data and plot them in OpenFOAM. Thanks for watching, and happy foaming.